Good morning, everyone. Welcome back. So let's go ahead and finish this proof. So recall the last video, we have arrived at the left hand side equal 4 cosine square 5x minus 3 over 4 cosine of x minus 3, right? And we want to show it eventually equal to this red on the right hand side right here. So with that being said, I'm going to introduce another two theorem or lemma we can use so we can conquer the problems, okay? So let's go ahead and get started. So let me see, lemma 2. So this is lemma 3. Basically, it's just a small tools you can use if you don't want to think about lemma like in a traditional complicated way. You just think about like, it's a small tool. It's like a good equipment you can use to find the dragon, right? To find the final boss. So what's lemma 3 can be like? So I'm interested in this sum. Cos u plus v plus cosine, u minus v. Okay, so let's go ahead and expand it and see what we got. So it will be cos u cos v minus sin u sin v. Okay, plus cos u cos v plus sin u sin v. Okay, and if you simplify it, you get 2 cosine of u times cosine of v. Wonderful, wonderful. So notice there's another way you can write it. So you can say that 2 cosine of u cosine of v equal cosine of u plus v plus cosine of u minus v. Or in other words, cosine u times cosine v equal to cosine u plus v plus cosine of u minus v over 2. Okay, wonderful. So let's see how we can apply this theorem later. I want to introduce you another one as well. It's just the subtraction. So let's go ahead and introduce it as well. So lemma 4. So what's our lemma 4 is going to be like? Cosine of a plus b minus cosine of a minus b. Yeah, we're interested in these. So let's go ahead and see what we can achieve from here. So cosine of a plus b minus cosine of a minus b equal to sine cos, my bad. So it will be cosine of a cosine of b minus sine a sine b. Okay, that's the first term. Cos a minus b is going to be equal to cos a cos b cosine b plus sin a sin b. Right, and then you simplify it, you get negative 2 sine a sine b. And notice I'm gonna do an important substitution. So if you substitute, right? If you substitute, you're gonna substitute what? You substitute a plus b equal to u. I'm not gonna write equal so that confuse you guys. A plus b you substitute to u, and a minus b you substitute to v. So you get what? You get a equal to u plus v over 2, b equal u minus v over 2. And if you plug it in the original expression we have for lemma 4, we get cosine of u minus cosine v equal to negative 2 sine u plus v over 2 times sine u minus v over 2. Okay, very, very important. These two theorem right here is what we're going to use later. Okay, the first one is the multiplication of 2 cosine, and then the second is the subtraction of 2 cosine. Okay, so we're gonna use these two, but how we're gonna use them? Let's see, where's our proof at? So we have come here, right? We have show the left hand side equal to 4 cosine of a 3a minus 3 over 4 cosine of a minus 3, correct? Yeah, x. Oh, it's not a, it's x. It's, just make sure it's the right variables. All right, so when you come to this point, what you're gonna do next? So what you're gonna do next is, I want to make a small change. It turns out that the denominator is not really helpful in this form. I need to transform it to another form or to an equivalent form. So for cosine square of x minus 3, I'm just gonna return it back to cosine 3x over cosine of x. You guys will see why in a minute. But in this case, the denominator need to change the form, okay, to an equivalent form. That's what I'm trying to say. So keep the denominator the same. I would change it back to cosine 3x over cos x, right? Sure, I did it right, yeah. And we can time cosine of x for denominator, and denominator you get 4 cosine square 3x minus 3 times cosine of x over cosine of 3x. Okay, what's next? Multiply it out, so you get it equal to 4 cosine of x cosine square 3x cosine of x minus 3 cosine of x over cosine of 3x. Okay, here's where the magic happened. Wait, 3x. Oh my gosh, guys, it's not 3x, it's 5x. I'm so sorry. So this is 5x. My bad. This is 5x. I copy paste wrong. That's basically the reason why. Yeah, I think it looks like it's 3x at the first, right? But when you look at the theorem, it's not. It's actually 5x. So it's 5x. Okay. 5x. Okay. Now you come to here. You notice this term right here. Notice this 4 cosine square 5x cos x. We can rearrange in a way that we can use the lemma we just proven previously. So let's go ahead and rearrange them. So I will write them like this: 2 cosine of 5x times cosine of x, okay, and then times 2 cosine of 5x minus 3 cosine of x over cosine 3x. Okay, you see this is multiplication of 2 cosine, right? So we can use this term right here from lemma 3. Okay, so it's cos u plus v plus cos u minus v. So you get cosine of 5 minus x, 5x minus x is 4x, plus cosine of 5x plus x is 6x, right? And then all this times 2 cosine of 5x minus 3 cosine of x over cosine of 3x. And this is from lemma 3. Okay, let's go ahead and keep expanding. You see how it can expand. So it's really very interesting. If you keep expanding that, you get 2 cosine of 6x times cosine of 5x plus 2 cosine of 5x times cosine of 4x. Yeah, just multiply it out. Minus 3 cosine of x over cosine of 3x. All right, you see, we get another multiplication of 2 cosine. We can use lemma 3 again. So cos x and cos 5x, what's that? So it's cosine of 6 plus 5x, so it's 11x, right, plus cosine of 6 minus 5x is x. Okay, that's for the first multiplication term. The second multiplication term, 5 times 4. So cosine of 5 plus 4 is cosine of 9x. Cosine of 5 minus 4 is cosine of x. Minus 3 cosine of x. Over cosine of 3x. Okay, and let's see if we can simplify these. Yes, we can. So cosine plus cosine 2 cosine. 2 cosine minus 3 cosine is negative 1 cosine. So let me write this from lemma 3. From lemma 3. So we got cosine of 11x plus cosine of 9x minus cosine of x over cosine of 3x, right? Wonderful. Now you see is the we're almost there. You can feel it, right? Because cos 9x, cos 3x, you can eliminate it, and cos 11x minus cos x. Let's see what is cos 11x minus cos x. So let me go ahead and rearrange and group them so we can know what to do next. Minus cosine of x on this over cosine of 3x, right? Plus cos 9x. So instead of 9, I'm going to write 3 times 3x over cosine of 3x. Okay, so do you remember this theorem? Cos 3a over cos a, we have shown it in the past. Right here, lemma 2. Wait, lemma 2. Yeah, there we go. So that's the cos 4 cos square minus 3. So from lemma 2, this one, you get 4 cosine of 3x, cos square of 3x minus 3. Okay? And how about this term? Remember the 2 cos minus together? What will we have? The 2 cosine minus together, we will have, here is from lemma 4, right? 2 cosine together is negative 2 sine of the sum divided by 2, and the subtraction divided by 2. All right, so let me write this lemma 4. You will get negative 2 sine of the sum divided by 2. So 11 plus 1 is 12. 12 divided by 2 is 6x. And then you get the subtraction divided by 2. So 11 minus 1 is 10. 10 divided by 5 divided by 2 is 5x. Over cosine of 3x. Right? So let's see if we can simplify this term further. Oh, okay. Sine 6x. Do you remember sine 6x from lemma 1? I think I will show it. Lemma 1. Yeah, so it's just sine 2a, right? It's 2 sine a cos a. So I can keep on rewriting it. So negative 2 times 2 sine 3x cosine 3x times sine 5x, right? Over cosine of 3x. And then this is from lemma 1. And this, the term on the right, still rewrite the same. So 4 cosine square of 3x minus 3. And yes, we have canceled the cos 3x. So we get negative 2 times 2 sine 3x times sine 5x plus 4 cosine square of 3x minus 3. You notice how I didn't multiply negative 2 with 2 to get negative 4, because I know this form is more useful, and you see why in a minute. So this is 2 sine times together, right? And I think we have an expression for that. Do we have an expression for? Yeah, okay, here we go. Is this one. It's a little bit more subtle, but we only it's from lemma 4. You see the one I highlight in yellow. So negative 2 sine of 2 things together is the subtraction of the cosine, right? This the cosine of the sum subtract to the cosine of the minus. Okay, so We apply lemma 4 again. Oh, my bad. Oh, I'm so sorry. Yeah, there you go. It's gone. Just like that. So let me go ahead and say lemma 4. So that would be, it's -2, right? So let me, first I'm going to do this. I'm going to do this. I'm going to put the negative sign right here. And then I'm going to say this is 2 times cosine of 5x minus 3x minus, right? Or some, let me see. It's the addition first, and then minus the subtraction. 5x minus 3x plus cosine squared 3x minus 3. And you do some simplification, you get 2 times cos 8x minus 2 cosine of x plus 4 cosine square of 3x minus 3. Okay? And 4 cosine square of 3x minus 3, what is cosine square? Okay, if you recall, I mean I can do a lemma 5, but I'm just gonna say recon right here. So if you recon your cos 2x, or cos, yeah, it should be a. I don't want to confuse you guys with characters. Cosine 2a, it's gonna be 2 cosine square a minus 1, right? So you can solve for 2 cosine square a is equal to cos 2a plus 1, or in other words, 4 cosine square a is equal to 2 cosine of 2a plus 2. Yeah, you're gonna substitute this in here. You get 2 cosine of 8x minus 2 cosine of x plus 2 cosine of 2 times 3x, which is 6x. So this is 6x plus 2 minus 3. And if you do some simplification, you get 2 cosine of 8x minus 2 cosine of x plus 2 cosine of 6x minus 1. Okay, and see, is this the result we have? Simplify with -1 minus -2 cos 2x to 6a. Plus 2 plus 2. I think it's similar, right? Oops. This is cos 2x. I got cosine of x. Oh, let me see. Let me check. Oh, it's 2x. 5 minus 3 is 2, guys. I'm so silly. This is 2x. Yeah, this is 2x. Yeah. Yeah. So, yeah. So this is the result we arrive at. Is similar to the result I just present you. This is the right hand side, so you can say when you finish a math proof, you can write QED. But yeah, you can verify this using Mathematica. Mathematica just use, I think, the simplified function. So this is it for the end of the video. This theorem is going to be very useful for evaluate the integral. So basically, you just square it, and you can just keep on simplify them like how we simplified before. Okay, because this is a integral of a square. All these square, right? So you can just square them, but this will be way more easier than, you know, than if you keep this form, like 2 multiplication divide for each other and then square it. It won't get you anywhere. Okay. So I appreciate everyone's attention, and also please go back to the first part. I have the link for the another way to do this. Like I think a YouTuber, he solved this problem. It's a very interesting way, in a complex number way, I think. And yeah, I hope you have a good times, learn something new today, have some fun, and most importantly, I wish you have a meaningful life. Okay, thank you everyone for your attention.